at some multi-step proportion problems. First of all, what is a proportion? Essentially, a proportion is setting two ratios equal to each other. So for example, I'll give you just a simple example. Let's say that 1 out of every 2 people in this classroom are girls. 1 out of 2 are girls. And let's say that there are 50 girls in the class. That must mean there are 100 students total. 1/2 is equivalent to 50 over 100. Another example, let's say that we had 9/27. That reduces to 1/3 as a proportion, two ratios that are equal to each other. Direct variation uses a proportion. Direct variation means that as one value gets bigger, the other one gets bigger. If one value gets smaller, the other one also gets smaller. Example, the number of items you buy, as that gets bigger, the amount of money that you spend is going to get larger. Another example, moving in the opposite direction, things getting smaller. The smaller your waist is, the smaller amount that you're going to weigh in general. So let's look at what the equation would be for direct variation. And it works like this. You're going to take the relationship that you have and divide them by each other. So relationship 1 is going to equal the relationship 2. Example. Find the cost of 4 donuts if a dozen donuts cost $3.60. Well, 1 dozen donuts, that's 12. 12 donuts cost $3.60. So find the cost, that's going to be on the bottom, of 4 donuts. This once again is direct variation. The relationship here is the cost for donuts. Relationship here is also cost for donuts. Across the top of these fractions, they're both donuts. Across the bottom, they're both going to be in dollars. So when you make a direct variation proportion, you need those relationships vertically and horizontally. To simplify this, we could multiply both sides of the equation, essentially cross-multiply. Multiply both sides of the equation by y and by 3.60. It's going to give us 12y equals 4 times 3.60. And then we could multiply 4 times 3.60, and we get 12y is 14.40. It's $14.40. And if we divide both sides by 12, we're going to get 1.2. Talking about money, so we should do decimal places. We get $1.20. That's one way to do this problem. Another way to do it is using a rate. And those chemistry-like conversions we did in a previous lesson. So if you look at the rate, it says a dozen donuts is $3.60. We're supposed to find the cost of 4 donuts. So we are essentially going to take 4 donuts, you can write it as a fraction if you want. We want to multiply it by something in the form of 1 so we can figure out what the cost is. Well, if we write this ratio, dozen donuts to $3.60 as a ratio, we want dozen on the bottom, so it cancels with the donuts on the top. And that is equivalent to $3.60. Now the units that we're in is in dollars. We do some more canceling here. We can divide both 4 and 12 by 4. So we end up with $3.60 divided by 3, and that once again is $1.20. You can do this problem in 2 different ways. They both work wonderfully whichever way you're more comfortable with you would want to do. Number 2 here, got a plane moving at a constant speed of 3,000 miles in 6 hours. How far will the plane fly in 8 hours? Once again, there's 2 different ways you can do this. If we write 3,000 miles over 6 hours, that fraction is equivalent to 1, because those are 2 equal things. Every 3,000 miles, you get 6 hours. For every 6 hours, you get 3,000 miles. How far will it fly in 8 hours? Well, if we multiply this by a fraction, we want the 8 to cancel, and the bottom is just going to be 1. So this is not equivalent to 1. This fraction here is not equivalent, because our answer is not going to be equivalent to 1. So as far as canceling goes, we got hours on the top and bottom. We can also divide both 6 and 8 by 2. We can also divide 3 and 3,000 by 3. This ends up being 4,000. What units do we have left? We have miles left. So it's 4,000 miles. If you set this up as a proportion, you're going to get the same answer. Let me just show you that real quick. It says that this plane is going 3,000 miles in 6 hours equals the difference between the proportion, you're setting things equal to each other, and in the conversion formulas you're multiplying a series of fractions where one of those fractions is not 1, but all the rest of them are. So we got miles on top, so we're going to have miles on top here, which we don't know how many miles that is. And then we have hours on the bottom. And then if you cross multiply here, or if you just multiply both sides by 8, and if I label that 8 when I bring it over, hours cancel, we're left with miles. If you put that in your calculator, you're going to also get 4,000 miles. So if both those ways make sense to you, pick whichever way is faster, because the ACT is all about speed. If a kickboxer can kick 320 heads in 5 minutes, how long will it take to kick 480 heads? So I'm going to once again just do this as a ratio and multiply it by a series of 1s, or 1, 1 in this case. We got 480 heads that need kicked. I'm going to write it as a fraction. I'm going to multiply this by a ratio that's equivalent to 1. 320 heads happens in 5 minutes. I want heads to cancel, so I have 320 on the bottom. It's important to label your numbers. We got 5 minutes on top. As far as canceling goes, heads cancel. You can do some division here to get this simpler, but you know what? What's the point? We want to save time. If you multiply 480 times 5 and then divide it by 320, .480 times 5 is 2,400. Divide that by 320, and you're going to get 7.5. It asks for minutes. How long will it take? It'll take 7.5 minutes. Number 4, if 20 butterflies weigh 25 ounces, how much do 15 butterflies weigh? So we're trying to figure out the weight of 15 flies made of butter. I'm going to multiply this by a ratio that's equivalent to 1. 20 butterflies weighs 25 ounces. I want the butter to cancel. That's going to go on the bottom. I got 25 ounces on top. Butterflies cancel. If you put this in your calculator, multiply the top numbers and divide by the bottom, you get 18.75 ounces. There you go. So how this relationship works for inverse variation as one gets bigger, the other one gets smaller. When you have a relationship between two things, you multiply them together instead of dividing them. Example of an inverse relationship: the more hours I exercise, that number gets bigger. The less I'm going to weigh, that number is going to get smaller if I'm trying to do cardio. Or that's a good enough example. Let's look at example 1. A train trip from Cleveland to Denver takes 4 hours if the train travels 125 miles per hour. So the relationship here is that 4 hours at 125 miles per hour. So we are supposed to multiply things in a like relationship. So 125 miles per hour times 4 hours equals, how long will the trip last if the train travels 20 miles per hour? So we set it equal to 20 miles per hour times some unknown time. Well, if you multiply 125 times 4, you're going to get 500. Let's forget about the labels for now. Let's make it simpler. And if you divide both sides by 200, using the division property of equality for real numbers, you end up with 2.5 equals y. It says how long, so that's going to be measured in hours. 2.5 hours.